So first, let's remember the formula for integration by parts. We have the integral of u dv. This will equal u times v minus the integral of v du. So that's our integration by parts formula. The other thing that we might want to remember is how to integrate simple exponential functions and some trigonometric functions. So first, let's look at derivatives and integrals of simple exponential functions. So if we take the derivative with respect to x of the function e to the ax, where a is some number, this will be e to the ax times a because of the chain rule, or a times e to the ax. What this means then is that if we integrate e to the ax with respect to x, we will have 1 over a times e to the ax. And if we take the derivative with respect to x of the cosine of ax, well, this will be negative the sine ax times, again by the chain rule, a. And what that means then is that if we're integrating the sine function, sine of ax, with respect to x, that our result will be minus 1 over a times the cosine function. For the first example, let's look at the integral of x times e to the 5x dx. So now we're going to apply integration by parts because we see here a product of two functions. And the way we're going to set this up is we're going to let u equal x, since this is an algebraic function, and then everything we have remaining, e to the 5x dx, is going to be set equal to dv. In order to apply our formula now, we also need to know du, and we need to know v. So if u equals x, then du dx is equal to 1. It's the derivative of x with respect to x. So this means that du will equal dx. And here, to find v, we're going to integrate dv. So we're going to have the integral of e to the 5x dx, and that is 1/5 e to the 5x. So now, applying our formula, we have that the integral of u dv is going to equal u times v, so the product of these two, so x over 5 times e to the 5x, minus, and this is our integration by parts, negative sign, the product of, or the integral of v du, so the integral of 1/5 e to the 5x dx. And now this is an integral that we can solve. So we have x over 5 e to the 5x minus the 1/5 is a factor out front. When we integrate e to the 5x, something we've actually already done, it's 1/5 e to the 5x plus some constant of integration. So if we want to rewrite this and simplify it a little bit, we have x over 5 e to the 5x minus 1/25 e to the 5x plus a constant of integration. So doing that last problem was a lot of work, and there's actually a shortcut that we can do and get the same results more quickly. So what we're going to do is set up a table, and in the left-hand column, we're going to put the u function, or the function that we're taking the derivative of, and in the right-hand column, we're going to put the dv, or the function that we're going to be integrating. So in this example, we would have x here and e to the 5x there. Those were our u and dv in the previous example. Now we take the derivative in this column, so the derivative of x is 1, and in this column we integrate, so the integral of e to the 5x with respect to x is 1/5 e to the 5x, And now we're going to do this again. The derivative of 1, it's a constant, is 0. And when we integrate this, we'll have 1/25 e to the 5x. And now when we've reached 0 in this column, our answer to the integration by parts problem will be positive the product of these two entries in the table, and then minus the product of these two entries. So in other words, the integral we started with, x times e to the 5x, will equal this product, so x over 5e to the 5x, minus this product, 1/25 e to the 5x, and plus our constant of integration. Notice that we got the exact same result we had previously. It was just a shortcut to get to the answer. For the next example, let's look at integrating something that involves a trigonometric function. So x times the sine of 5x dx. We will let, again, u be our algebraic function, so u equals x, and then everything remaining, sine of 5x dx in this case, will equal dv. So now, in order to apply the formula, we need to find du. So du is just going to equal dx, and v will be the integral of dv, so we want to integrate sine of 5x, which will be minus 1/5 cosine of 5x. So then our integral of x times sine of 5x is going to equal the product u times v, which will be minus x over 5 cosine of 5x, minus, and this is the integration by parts minus sine, the integral of v du, which will be minus 1/5 cosine of 5x dx. So now, this is something that we can integrate. So this will equal minus x over 5 cosine of 5x, plus, combining these two minus signs. Now what is the integral of cosine of 5x? So we'll have this 1/5 here out front, and the integral of cosine of 5x is 1/5 sine of 5x. And we have our constant of integration. So our answer then, if we clean it up a little bit, will be minus x over 5 cosine of 5x plus 1/25 sine of 5x plus a constant of integration. So now let's look at the same problem, only using our shortcut. So remember here, we set up a table, and on the left, we're going to put the function that we're taking the derivative of, the algebraic function in this case, and over here, we're going to be putting the function that we're integrating. So here, the u and the dv. So in this case, u was x, and dv was sine of 5x. And now in this column we take derivatives, so the derivative of x is 1, and in this column we're integrating, so the integral of sine of 5x is minus 1/5 cosine of 5x. And then we repeat this process. Now the derivative of 1 is 0, and here if we were to integrate, we would have minus 1/25 sine of 5x. So now, the answer to our original problem will be the product of these two entries, so minus x over 5 cosine of 5x, and then minus the product of these two entries, so minus a minus 1/25 sine of 5x plus a constant of integration, or minus x over 5 cosine of 5x plus 1/25 sine of 5x plus a constant of integration. So exactly the same result that we got before, only using this shortcut, we're not writing out all of the steps with the u's and the dv's. We're simply putting those into a table. So for the next example, let's look at integrating an inverse trigonometric function. In this case, we're integrating the arctangent of 5x. So let's look at the types of functions we have. In general, we have logarithmic functions, we have inverse trig functions, algebraic functions, trig functions, and exponential functions. And what we're going to do is we're going to put in the derivative column of the table whichever type of function that we're integrating that comes first in LIATE. So here we're integrating an inverse trig function, and we don't have anything else, so we're going to put in the derivative column of our shortcut table the arctangent of 5x. So what do we put in the integral column? Well, in this case, all we have left is dx, or 1 times dx, so we put in a 1 here. Now we take the derivative in this column. The derivative of the arctangent of 5x is 1 over 1 plus the quantity 5x squared times, because of the chain rule, the derivative of 5x, which is 5. And here in this column, if we integrate 1, we just have x. Now what we notice here is that the entries in the derivative column are not going to 0, or getting more simple. So what that means is that our original integral will equal the product of these two entries, so x times the arctangent of 5x minus the integral of the product of these two entries. So minus the integral of 5x over 1 plus, and here I'm just going to write 25x squared. And now we ask ourselves if this is something we can integrate. Well, yes, we can integrate this using substitution. So let's do a little u substitution off to the side. We are going to let u equal 1 plus 25x squared, and then du will equal 50x dx. So this integral becomes the integral of, well, we have u in the denominator, and then what we have left over is a 5 times an x dx. Well, the x dx can be replaced with 1/50th du, and then we have this factor of 5 here, which we can just also write out front of the integral. So essentially we're going to be integrating 1/10 1 over u du, or this. And this is going to equal 1/10 times the natural log of the absolute value of u. And our u was 1 plus 25x squared, which will always be positive. So we have 1/10 times the natural log of 1 plus 25x squared. So now our original problem integrating the arctangent of 5x becomes x times arctangent of 5x minus, and now the answer to this integral here, which was 1/10 the natural log of 1 plus 25x squared plus a constant of integration.